Now let's take a look at now a slight twist on the applications of compound interest or on just continuous or on the exponential growth. Okay, so we're going to look at now continuous growth / decay models. So far what we've said is that we've had exponential growth that would be at certain time periods. So for instance, when we talked about the money, we said that it was going to be compounded at certain times throughout the year. What if instead this is being done continuously? So the continuous growth / decay model, this is going to be A of t is equal to A times e to the RT. So this A of t, this is the amount after some number of years. Now this E that we have, E is a constant. So your calculator, if you look on your calculator, you should see a button that says something like maybe E or E raised to some x power. E, all it is just a number. So E is going to be roughly 2.7, say 1828. It's basically this number that's between 2 and 3. It's somewhat like pi. For instance, if you think about the number pi is 3.1415926, so on and so forth. So E is similar to that. All this is just a letter that's corresponding to some number. Okay, so this is now my base. My base is going to be E, but then there's A in front. That's the initial value / amount. There's R is the rate of whatever our continuous growth rate per unit of time is, and T is going to be our time. So we're going to use this a lot when we start to model various functions. We're going to keep coming back to this one because this is our general growth and decay model when things are growing exponentially. Now, in particular, we can adjust this for the business people who want to use slightly different variables. So this is going to be a little bit more like what you saw with the compound interest. Instead of it being compounded a certain number of times per year, it's being compounded continuously. So our formula is going to be A of t, which is the same as this, is equal to P. So instead of an A, we have a P. Because in the finance world, we're talking about this principal or this initial investment. But that's the same as the initial value. So these formulas, that P is and the A are basically the same. R is the interest rate. So that is our continuous growth rate per unit of time. Our interest rate is R, and then T is the number of years, so that's time. So these two formulas are identical. Don't be confused by them. It's just using the types of notation that business people would prefer to use. So let's take a look at an example now. So suppose you invest $20,000 into an account that pays 6.5% interest compounded continuously. How much is in your account after 20 years? So we just did one that used compound interest, but I said that was being compounded daily. So if it's being compounded either daily, weekly, monthly, quarterly, semi-annually, all of those, that's when you use the other formula. But here, because it says compounded continuously, that tells us that we want to use the formula that A of t is equal to P times e to the RT. That is the only word that tells us to use this formula as opposed to the previous one. And now we just plug in our information that we know. So our P is our initial investment, which is $20,000. This E, that's just a constant, will allow the calculator to deal with that. Our R is this interest rate. This is our interest rate. So our interest rate is 6.5%. Remember, we need that as a decimal. Never, ever, ever do computations with percents. So we have 0.065. So we have 0.065, and then the exponent that's being multiplied by then is the number of years, which we said is 20 years. So when you put this into your calculator, again, pull that out, practice this, see if you get the same answer that I do. Remember, make sure that this whole exponent, you have parentheses around it. So the whole exponent is being raised to this. And so what we get as a final answer is $73,385.93. So that's the only difference between the compound interest being done at certain times versus continuously. We just use a slightly different formula, but everything works out roughly the same as long as you're able to get this answer on your calculator.